All right, so moving on the homework, we're looking at problems 6.61 and 6.65 together. These two problems are talking about power, and power is going to be defined as work done over a certain period of time. And so that's going to give you joules per second as far as your units go, joules divided by seconds. And that's going to be the same thing as something called the watt. Okay, you can write it out like that, or we can say that this is just W. Now, it's kind of weird to say W whenever we're working with work, but in the variable sense, work is W. In the unit sense, watts is going to be W. A little bit to keep track of, but I think you guys can do fine with that. So looking at 6.61, we have an outboard motor, 6.61, and it says this outboard motor has a power rating of 35 horsepower. Okay, now a horsepower is essentially the amount to take an average working horse way back when, and they had it do work. Okay, didn't overstress it, didn't understress it, just said, hey, what's the average amount of stuff that you can do? And it was lifting stuff, moving stuff around, and they measured it out to be some value. And they said, well, this is 1 horsepower. If you wanted to convert that to joules, which is what we're going to use in this class, 1 horsepower is equivalent to 746 joules of energy per second. So 1 horsepower is that many joules per second, or 746 watts. Another way to say that. Now, for this problem, it says if it can move this, if this motor can move a particular boat at a steady speed of 32 kilometers an hour. So we're at a horsepower of 35, and it's moving this boat with a velocity of 32 kilometers per hour. What is the total force resisting the motion of this boat? So let's think about what's happening here. You've got a boat, and it's in the water. Let me draw us a little picture here. And we got this motor in the back. So here's this motor, and it's kicking. It's got this propeller. There you go. And little bubbles, whatever. And it's near you can't even see it, but there you go. And there's a little stick thing, and there's somebody holding onto it, holding onto the boat, and saying, all right, we're going this way. So there's your boat. And as this boat is pushing forwards, there's stuff resisting it. There's going to be the water that's in the way resisting it. You can consider that as friction, but really you're trying to move the water. You're trying to add momentum to the water, and if you're going to do that, the water's going to put a force back on you. So we got this going on. Now this boat is putting out 35 horsepower, 746 times 35 joules per second in order to do this. Unfortunately, this boat's not moving any faster, so any amount of energy that's being put into the boat is being taken out of the boat, and that's kind of the issue here. So it says, what is the total force resisting the motion of the boat? And so what we're going to have to do is we're going to have to look at units a little bit. And let's get into standard units. So we have 35 horsepower, and I want this to be in joules. So looking at my conversion, 1 horsepower is going to be 746 joules per second. Now, some of you are still really bad at converting units, and I'll admit sometimes I screw up with it too, but just bear with me here. If we want to get rid of horsepowers, I probably want to divide this thing by horsepowers. And if I want to replace it, I want to replace it with watts or joules per second. So let's just put it right up here. Now, what do we know about this conversion? And this is where a lot of you get tripped up, is just how to do this. 1 horsepower, we're trying to get rid of it, so we're going to divide by it. Horsepower divided by horsepower is 1. X divided by X is 1. Y divided by Y is 1. That's what we're doing. And we're going to replace it. And this is a conversion factor. So what do we know? We know that 1 horsepower is how many joules per second? 746. And so what this does is this says that, hey, horsepower divided by horsepower is gone. It's just 1. And 35 times 746 is how many joules per second we have. And doesn't that make sense? We have 35 horsepower. We have 35 of these. Okay? So 35 times 746 gives me 26110. So 26110, and that's going to be in joules per second or watts. Now, we have 32 kilometers per hour, and I want this in meters per second. So first of all, let's go ahead and get rid of kilometers. If I have kilometers on top, I want to divide by kilometers. If we multiply across, and I want to replace that sucker with meters. Now, who's bigger, kilometer or a meter? Well, kilometer's bigger. So for 1 kilometer, how many meters do we have? A kilo is 1,000, and so I have 1,000 meters per 1 kilometer. Other side, I want to get rid of hours. Hours is on the bottom, and we know that we need to have hours divided by hours, so the only way to do that is to put hours on top. I want to replace it with some other unit of time, and that's going to be the seconds. And who's bigger, 1 hour or 1 second? Well, 1 hour is. How many seconds are there in an hour? Well, there are 60 minutes in an hour. There are 60 seconds in a minute. So we have got about 3600 seconds, 3,600 seconds in 1 hour. And that should cancel out all of our stuff. So kilometers, kilometers, hours, hours, leaves you with meters per second. And so we've got 32 times 1,000 divided by 3,600. And I get 8.888 forever. So 8.88 forevermore meters per second. Now, if you've got to pause this video, if you've got to stop it, you're probably watching this alone, right? So stop the thing if you're stuck here. Stop the thing if you're stuck there. Go back and actually listen or redo what I just did, okay? Because it's one thing to just listen and watch. It's another thing to actually do it. So see if you can do that. See if you can work it out. So what I notice here is that we got horsepowers turned into watts. We've got meters per second or kilometers an hour turned into meters per second. And back to the actual question itself, it says, what is the total force resisting the motion of the boat? So we're looking for force. And what is force? Force is in units of newtons, right? And newtons are in units of kilogram meter per second squared. And so, hanging them out of the camera. There you go. And so if we're talking about newtons, kilogram meter per second squared, and I'm looking over here at my joules per second. What is a joule? A joule, as far as unit goes, is a newton meter. And as far as what we just said, a newton is a kilogram meter per second squared. So that's kilogram meter per second squared times meters. So my units for the joule is kilogram meter squared over second squared. And here we're dividing by seconds again. So the units here are actually kilogram meter squared over seconds cubed. Now what does that even mean for us? Okay, that's kind of the big question. We have units here. This is the power rating. We've got just regular newtons here. What's the difference between these two? Do you see it? We've got meters squared, we've got meters over here. The difference is that this has another meters on top. What's the difference with the bottom? We've got another seconds on the bottom over there. So over here we have an extra meters per second than we do down here. And if we want to make this the same thing, if we want to make force, the unit of force is the newton, that's what we were just talking about. If we want to make this the exact same thing, then we need to multiply by meters over seconds. What is meters over seconds? That's velocity. Okay, so come back with me, think about it. We've got units of power, and we've got units of force. The difference is that we're missing meters per second, and that's from velocity. So if we took force times velocity, that gives me power. So what does this tell us? This tells us that for something that is moving at a constant velocity, like we're pouring energy into it, but we're constantly taking energy out because of friction or something in the way, the power that we're putting in is equal to a force that we're applying times the velocity that we're moving at. And so in this problem, I know this is kind of long-winded to get here, we are going to take our power, 26,110. We're going to divide that by our velocity, 8.88 forever, and that's going to give me the velocity that we're going to be moving at. Or that's going to give me the, not the velocity, the force that we're moving at. Sorry. 26,110 divided by 8.8 for as long as I can do it. And I get 2937. So 2937 point, let's say 4, and that's the newtons. That's the force that is resisting my boat. That's the force that this boat is pushing with. And so for this answer, you're looking for, 2 sig figs, so 2,900. That's going to be that. Now, the next part of this, the next one, I know that was actually kind of long. Sorry. But here's the next part, 6.65. Try to go a little bit faster. That was just me trying to explain power to you guys. 6.65 says that you have a sports car, and let's see, the mass of this sports car is equal to 825 kilograms, and we go from rest to 95 kilometers an hour in 6.4 seconds. So the time is 6.4 seconds. The final velocity is 95 kilometers per hour. Well, let's get this in the standard units first of all. Kilometers an hour to meters per second. Just like what we just did, we've got to get rid of kilometers. So let's go ahead and divide by it. Replace it with meters. 1 kilometer, 1,000 meters. Hours, get rid of it, put it on top. Seconds, we want it on the bottom. Okay, so 95 times 1,000 divided by 3,600 gives me about 26.39 meters per second. Okay, and it says, what is the average power delivered by this engine? So the car accelerates from 0 to 95 kilometers an hour in 6.4 seconds, and you got to think about what's being done. So power is the work done over some period of time. Well, we got the time. We got that. We need to figure out this work. Now, what does work do? Work is a force applied for a distance, at least in the same direction as a distance. You might have to use sine or cosine for that. Usually sine, or usually cosine. But what does work really do? Work, if you push on something, you're going to change its velocity. Work is going to change the kinetic energy. So work is equal to the change in kinetic energy. Usually. It's how much kinetic energy you're trying to put into it. Or take away. And so, with kinetic energy is 1/2 mv squared. And we're changing the v here. So in this problem, power is equivalent to the amount of kinetic energy that this thing got after the time that it was allowed to go. And we have all of that. We can just plug it in. So power is equal to the 1/2 m, what is m? 825. The change in velocity was from 0 to that, 26.39. We're going to square that. Divided by the time that it took, 6.4 seconds. And let me see what we get. We get half of 825 times 26.39, square it, divided by 6.4. And that's going to give me an answer of 44,887. So 44,887 watts. And that should be it.